Now we were seeing about the different reabsorptions happening in the nephron. We saw yesterday till this part, right? Till that it was 100. Now we'll be moving towards the DCT and the collecting duct. So I'll show you a better picture. Wait. Yeah. So now in this you can see this was 100, and then in DCT, this part is the DCT. Here water reabsorption is happening, due to which the osmolality increased to 300. This 300 then enters the collecting duct. This is the collecting duct. In the collecting duct, the osmolality keeps on increasing. This is because of this water reabsorption, and this water reabsorption is due to hormone ADH, that is antidiuretic hormone. This antidiuretic hormone causes the water reabsorption and concentration of the urine, and it preserves water. So here we can see at the end of the collecting duct, finally we get 1200 of milliosmolality. This osmolality of the urine is responsible for telling us about the total water reabsorbed and conservation of water. Now moving on to the next slide. Yeah, and this also we can see this ADH. This ADH increases water permeability, due to which the water is reabsorbed, causing concentration of the urine, and finally we get 1200 milliosmolality of the urine. Okay, yeah. Coming on to the countercurrent mechanism. What is countercurrent mechanism? It is basically two tubes. What is countercurrent? Two tubes with fluid moving in opposite direction. This is what is meant by countercurrent. In this, what we see is, this is the blood vessel. This red part is the blood vessel, and this in the middle, this one, this is the nephron, part of the nephron. And what we saw was, this blood vessel is known as vasa recta, and this is the nephron with loop of Henle, this loop of Henle, this one. Now when we see the fluid moving, here we can see the arrow is downwards, whereas in the vasa recta it is upwards. So this is what is meant by countercurrent. In the nephron we already saw the water gets reabsorbed, water moves out of the nephron in the descending part here, and this descending part is responsible for the concentration of urine from 300 to 1200. This is just opposite in case of vasa recta. In vasa recta what happens is, this ascending limb of vasa recta causes water reabsorption. This water reabsorption leads to deficiency of water in the interstitium, which leads to this water coming out. Okay, so the descending limb is permeable to water, and the water moves out of loop of Henle, the descending limb, but there is reabsorption of water into the vasa recta. And which limb of vasa recta? The ascending limb. This is just opposite in the ascending limb of loop of Henle, and descending limb of vasa recta, just opposite. The direction of flow is just opposite. So in loop of Henle, in the ascending limb there is sodium chloride moving out of the nephron, so the urine gets diluted, urine concentration decreases as we move up. Whereas in vasa recta, as we move down the descending limb of vasa recta, the sodium gets absorbed and concentration in the blood, it keeps on increasing. So basically this countercurrent mechanism is the flow of fluid. One is the blood, one is the urine in opposite directions. Blood is by vasa recta, urine is by nephron. Okay, thank you so much.